Hey, what is up guys? We're back with another LeetCode video. Today we're going to be doing 1584, minimum cost to connect all points. So you were given an array of points representing an integer coordinates of some points on a 2D plane where points I is equal to xy. Okay, so it's just an array of points. The cost of connecting 2 points is the Manhattan distance between them, basically the difference between the x values and the y values, where val denotes the absolute value of val. Okay, return the minimum cost to make all points connected. All points are connected if there is exactly one simple path between any 2 points. This video is going to be really short. Some of you guys are probably going to hate me for it because I'm not exactly going to provide the code solution. And the reason is, I'll explain in 1 second. So we have the example, and you see we have this list of points, and we want to find the minimum cost it takes to have all these points connected. And basically, it's really simple. If you know 2 certain concepts, and that if you know 1 concept and 2 solutions for that concept, I guess, which is the idea of a minimum spanning tree, and what a minimum spanning tree is, and then the 2 solutions to that is either the Prim's algorithm or Kruskal's algorithm that will help find the minimum spanning tree. So what's a spanning tree? Is basically a connected non-cyclic graph, where all the points in the graph are connected to each other and there's no cycles. And the minimum spanning tree is basically one such spanning tree where all the points are connected and the cost of all the edges, of summing up all the edges, is at a minimum. And that's basically what this problem is. You're trying to find the minimum cost where all the points are connected. And so if you know what minimum spanning tree is, or what Kruskal's or Prim's algorithm are all about, then you'll get the answer just like that. So what I'll do instead for this video is I'll just link you guys a bunch of videos, if you don't know what those are, to just explain them. Because I don't want to waste my time or make useless new information that is already out there. So here are some good resources. The first thing I can recommend is watching well, the first thing is probably watching Prim's and Kruskal's algorithm reading method by Abdul Bari. He makes a lot of good videos, especially on graphs and algorithms. Or if you kind of know about them already and just need a refresher, you can watch these 2 really short videos. Kruskal's algorithm in 2 minutes, and Prim's algorithm in 2 minutes. And then also the William Fessett also has some great videos. I love watching his graph theory playlist. I went through a lot of those videos, and a bunch of his other videos as well. He has some good videos on Union Find as well, so I highly recommend those if you don't know what Union Find is all about. He has one video on Prim's spanning tree where he goes over the priority queue method of doing Prim's, and there's also one on Kruskal's algorithm where it involves Union Find. So that's that. So Prim's and Kruskal's by Michael Sambol, Prim and Kruskal by Abdul Bari is good too, and Prim's and Kruskal by William Fessett. And also Geek for Geeks also has 2 good videos where they walk through the code for doing something like this. So I just recommend just watching that. I don't want to redo that because it's already there. Also the discussion explains that as well. So that's that. Just check out all these videos. You'll get the answer right away. They're really good. There's no point in me explaining it again. One thing to keep in mind is this, where for Prim's algorithm for sparse graphs, there's 2 ways to do the Prim's algorithm. One is using the matrix way, which I think, if I remember correctly, Bari explains that way. And then there's a lazy way to do it, which is using the PQ, which is William Fessett's way. So for sparse graphs, the PQ is faster, and for dense graphs, the naive implementation is faster, because E is going to be equal to n squared if the graph is very dense, and you'll understand how that works if you just understand Prim's algorithm and Kruskal's. And that's basically the video for today. Not for today, for this problem. Number 1584, min cost to connect all points. I mean, once you look through the videos and just looking at some of the discussions, the answer will come just like that. So I hope you guys liked, enjoyed, subscribe, comment, and let me know if, or dislike if you actually want to see the solution. Sorry. I mean, I'm really a big proponent of making new videos, not videos that are already there, and just better content, right? Not content that's already there and just recreating. I don't want to use someone else's content and not give them credit and just, it's all already there. I'm just here to facilitate that. information.